First problem. We have discussed the depth of neutral axis and moment of resistance. Now we are going through some problems related to this. First problem is find the moment of resistance of a singly reinforced beam of 20 millimeter width and 400 millimeter effective depth, reinforced with 316 mm bars of Fe 415 steel. Take M20 grade of cone gauge. First we have to write the given data. Width of the beam is given as 200 millimeter, and depth of the beam is 400 millimeter. Given effective depth is given. Effective depth is given in question 400 millimeter effective depth. So the effective depth small d is 400 millimeter, and area of steel is given 316 mm diameter bar. So 316 mm area is area of the one bar multiplied by 316 means 3 numbers 16 mm diameter bar. So first find the area of the one bar 16 mm diameter bar multiplied by 3 numbers. So 3 into area of the one bar is 5d square by 4. So area of the one bar multiplied by 3, this is the total area of the steel. Then FCK is M20 grade cone gauge. So characteristic strength of cone gauge is 20 Newton per millimeter square, and using Fe 415 bars. So Fy is equal to Fe 415 Newton per millimeter square. These are the data given. Okay. Then the solution of this problem. First question is find the moment of resistance of a single reinforced concrete beam. So moment of resistance mu is equation. Let us calculate the mu. So the mu equation is this. This is the equation. This in page 96. The mu is equal to 0.87 Fy AST into D into 1 minus AST Fy by BD FCK. So all the data are given, but we have to first find out the XU max and XU and compare with which section is balance section or under reinforced or over reinforced. First we have to identify the section of the beam. So for that, first we start from the XU. XU is given in page 96. This page 96. Annexer G11A. This is XU is equal to 0.87 Fy AST by 0.36 CKB. This is the in textbook IS code. It is given as XU by D is equal to 0.87 Fy AST by 0.FCK BD. So XU is equal to the multiplied by D, we get this equation. Then substitute the values 0.87, Fy is 415. Substitute here. Then AST, area of steel. Then divide by 0.36. FCK is 20. Then B, breadth of the beam. Breadth of the beam is 200. So substituting 200 value. So solving this, we get 151.24 millimeter square. So this is the value of XU. Now we have to calculate the value of XU max. We know the XU max by D from page 70 under the note in assumption 38.1. assumption 38.1. Under that, there is a note provided. At that note, page 70, we know that XU max by D is equal to 0.48 for Fe 415 steel. Depends upon the grade of steel. For Fe 415, the XU max by D is 0.48. So therefore XU max is equal to 0.48 into D. It's given as XU max XU max by D is equal to 0.48. It's given in page 70. Page 70. And under the note, this XU max is based on the strength of the character strength of steel. For character strength of steel, Fe 415, this XU max by D is 0.48. So therefore XU is equal to, from this equation we get XU max is equal to 0.48 into D. That's given here. 0.48 into D. Therefore 0.48 into D is effective depth 400. Substitute the value of 400 here. So we get 19192 millimeter. So comparing these two, XU and XU max. XU is less than XU max. So the XU is less than XU max. Hence, we know that the XU is less than XU max is a under-reinforced section. So under-reinforced section, find out using this under-reinforced section, we have to find out the value of Mu. So from page 96, go to the equations. We know that for under-reinforced section, Mu is equal to 0.87 Fy AST into D into 1 minus AST by Fy divided by BD FCK. That is given in page 96. For under-reinforced, there are three equations are there: A, B, C. Page 96, G11, A, this is this equation, B, another equation, and D, another equation. So from this, Mu is equal to, for under-reinforced section, 0.87 Fy AST D into 1 minus AST Fy divided by BD FCK. Then substitute the value of all. So values of Fy, 0.8415, and then AST, we know AST, D we know, then again AST Fy, and B, put the B and D same, then FCK. All these values are put here: 0.87 into 415 into area T and D, then AST, again AST into FCK, Fy divided by B into D into FCK. So solving this, we get 73.48 into 10 raised to 6 Newton millimeters. Moment of resistance unit is Newton millimeter. So converted this into kilonewton meter. For converted the Newton millimeter to kilonewton meter, divided by 10 raised to 6. So 73.48 kilonewton meter. And there's another equation. Instead of this equation, we can use, this is the lever arm depth, x d minus 0.42 x cube. This is the lever arm depth. So stress in steel into area of steel. Stress in steel is 0.87 Fy into area of steel into distance. That is the lever arm. So we get the moment. The same equation. This term is used as d into 1 minus 0.42 x cube. And this equation already derived is from this equation. X cube is equal to 0.87 G11A. And that we get this 0.87 Fy AST into d minus 0.42 x cube. Again, substituting this value, we get 73.28 kilonewton. This is the first problem. I think I understand this questions and answer. Clear. And then we can move to next problem. The next problem is a reinforced concrete slab 150 millimeter thick. This is slab 150 millimeter thick. A reinforced slab. (150 millimeter) thickness of the slab is overall depth is 150 millimeter. And 10 mm dia bars. Bars are provided 10 mm dia bars. These are placed at a 180 millimeter center. So this distance is 180. So each bar is placed at a distance of 180. And the reinforcement is located at the effective depth of 125. That is, from the center to this distance. This distance is 125. This is 125. That is effective depth is 125. And the overall depth is 150. Calculate the moment of stress on the section. Use M20 grade concrete and Fe450. This is the question. Find the moment of resistance. Again, the question is find the moment of resistance. I read the question once more and explain the figure. The reinforced concrete slab. The concrete slab 150 millimeter thick, overall thickness, and 10 mm diameter bar. These are 10 mm diameter bar placed at a 180 millimeter center. That's these distances are 180 millimeter center. And reinforcement is located at an effective depth of 120 millimeter from top. This distance is from top is 125 millimeter. To the center of the reinforcement. Calculate the moment of resistance. Use the concrete M20 and Fe450. So M20 grade concrete is FCK is 20 and Fe415 Fy is 450. And area of steel is 10 mm diameter bar. So first find the area of one bar. 10 mm diameter bar. Pi by 4 d square. So this is the area of the bar. So the distance of the slab is not given. This is an RCC slab. We know the RCC slab. It's a very small thickness, 150 millimeter, but the length of the slab is more than the thickness, very large thickness. So the length is not given. So we consider only 1 meter width of slab. The design is for 1 meter width of slab. For slab, we have designed for 1 meter width. So therefore, to find the area of steel in 1 meter. So area of 1 bar is equal to this width, and therefore the number of bar in 1 meter is equal to 1 meter is 10,000. Sorry, 1000. 1 meter in millimeter converted to millimeter is 1000. 1000 divided by spacing 180 millimeter. So 1000 divided by 180 multiplied by area of 1 bar. So that is the area of steel in 1 meter width. So this is area of bar is equal to 1000 divided by 180. 180 is the spacing of the bar. This is 1080. 180 spacing, and for 1 meter it is converted to millimeter. This is millimeter. 180 is millimeter, so 1 meter converted to 1000 millimeter. So 1 meter divided by, we get the number of bar. Number of bar into area of 1 bar. That's equal to total area of bar in 1 meter. Again, we can for this problem, again we find out the XU and XU max and compare the section. Which section is this? Balance flow or over or under section. So first we calculate the XU. Same ditto problem, 0.87 Fy AST divided by 0.36 FCK D. This is given in page 96. Page 96, XU by D is given. So converted into XU is equal to. So XU is equal to 0.87, Fy is 450, and AST is this divided by 0.36, FCK is 20, and B is considered for a 1 meter width. So B is equal to 1000 millimeter. So solving we get 21.86 millimeter. That's the XU value. Then find the XU max by D. Again, XU max by D is given in page 70. Page 70. XU max by D is 0.48 for Fe450 steel. For Fe450 steel, XU max by D is 0.48. Therefore, XU max is equal to 0.48 into D. D is the effective depth. Effective depth is 125. So 0.48 into 125 is equal to 600 millimeter. So comparing these two, XU and XU max. Here XU is small, 21.86. The XU max is 60. So XU is less than XU max. Comparing, XU is less than XU max. So it is under inflow section. And XU is less than XU max, the section is under inflow section. So find the moment of resistance using under inflow section by MU. MU for under inflow section. So find MU is equal to 0.87 Fy AST into D into 1 minus AST Fy divided by BD FCK. This is given in page 96. Page 96, equation is given. This equation is given in page 96. So mu is equal to 0.87 Fy AST into D into 1 minus AST Fy divided by BD FCK. Now we substitute the values. All values are given. Fy is given, AST is given, effective D is given, B is given, FCK is given. All data are given, so directly substitute the this value is here 0.87. Fy is 450 and D is 125 and AST is 436.1 into 1 minus AST, again AST 43.1. Then Fy is 450 divided by B, where use width of slab is taken as consider the 1 meter width of slab. So B is equal to 1000 millimeter and the effective depth is 125. So this is 125 and FCK is 20 Newton per millimeter. So substitute 20. Now solving this equation, we get value 18.25 into 10 raised to 6 Newton millimeter. Convert this Newton millimeter to kilonewton meter, 18.25 kilonewton meter. Then this same problem can be do by another equation using Liverami value. The D minus 0.42x is Liveram. So Liveram by 0.875 AST into D minus 0.42 x2. Substitute the value of x2 here. x2 21.86 0.42. D is 125. AST is 436.1. Fy is 450.87. Then solving this, we get 18.323 kilonewton meter. Here solving we get this 18.23 in 10 raised to 6 Newton millimeter, then convert it into kilonewton meter. This is the second question. Read the question. A reinforced concrete beam beam 200 by 400 millimeter effective depth. The depth is 400 millimeters effective and is reinforced with 3 numbers 16 mm diameter bars. Calculate ultimate UDL, ultimate load, which the beam can carry safely over a span of 5 meters. Use M20 concrete and Fe 450 steel. Okay, I think everyone write the question. Then what are the data given? A reinforced concrete beam 200 by 400 millimeter This is 200. Width is 200 millimeter, and effective depth is from the compression zone to the area of the steel, center of the steel. This is 400 millimeter. Then 3 number of bars. Number of bars is 3. 3 numbers, 16 mm diameter bar. 3 numbers, 16 mm diameter. This is the question. And concrete is M20 concrete and steel is Fe450. Find the load which can carry, UD load. So this is a simply supported beam, across simply supported beam, and the span is 5 meter. That is given. The span is 5 meter. So find the UDL. Find the UDL. So question. So you know UDL due to the load, the bending moment is developed. So find the bending moment mu, and then we can find out the load. So first for that we have to find out the mu. For finding out the mu, first we have to calculate the xu and xu max and compare. Then calculate the mu. From the mu value we can find out the load. So data is given. Width of the beam 200, depth of the beam 400, FCK is 20, Fy is 415, span is 5 meter. I calculate the UDL. The beam can carry safely over a span of 5 meter. The span is 5 meter. And area of steel is 3 numbers, 16 mm diameter bar. So 3 into 5d squared by 4. So this is 300, 603.9 millimeter square. Okay. I think we've taken these values. Then solution. First we have to find out the XU. Take the page 96 IS code. Take the page 96 IS code. We get the value equation. XU by D is equal to 0.87. This equation. XU by D is equal to 0.87. Fy AST divided by 0.36 FCK BD. This equation. This we get XU is equal to 0.87 Fy AST divided by 0.36 FCK B. Then substitute the all values. FCK 0.87, same 0.87, Fy 415, AST 603.18 divided by 136 into FCK. FCK is 20. 0.36 B. B is which was B? 200. So B 200. Then only we get 115.2 millimeter. So we have to find out the XU max. XU max is given in page 70. IS code page 70. Take the page 70. Under the figure, a note is given. Under the note for Fy is depends upon the Fy. Our Fy is 415. For 415, XU max by D is 0.48. Therefore, XU is equal to 0.48 into D. Okay. Then substitute the value D here. 0.48 into D is 400. Then we get the value 182.0. And comparing XU and XU max. XU is 151. XU max is 192. 151 is less. So XU is less than XU max. Okay. So based on this XU and XU max, XU is equal to XU max is balance section. XU is equal to XU max is a balance section. XU by XU is less than XU max, it's an under reinforced section. If XU is greater than XU max, over reinforced section. So this is an under reinforced. Therefore, we find out the moment of resistance of under reinforced section in page 96. In page 96 IS 4. Take the page 96 of IS 456 200. G11 B. If the value of XU by D is less than the limiting value, that is XU max by D. Calculate the moment of resistance by following expression. MU is equal to 0.87 Fy AST into D into brackets 1 minus AST by Fy divided by BD FCK bracket cos. Then substitute the value of Fy AST, all values here. Right, 0.87 into 4 Fy is 415. AST is 603.19. Effective depth is 400. Then 1 minus point of AST Fy divided by BD FCK. Substitute these values. Solving, we get 73.48 into 10 raised to 6 Newton millimeter. Convert into kilonewton meter. Divide by 10 raised to 6. 73.48 kilonewton meter. Therefore, mu is equal to, or mu is equal to another equation. Mu is equal to 0.87 F by AST into D minus 0.42 X divided by 0.87 415 into 603.14 into 400 minus 0.42 into 151.2. Only 5 minutes remaining, so I quickly going to the remaining portion. Then find the ultimate load. This is the maximum ultimate moment of resistance. So mu is equal to, mu is equal to W. This is a simply supported with the UDL. So W L square by 8. WU ultimate load, WU divided by 8 L square. So mu is equal to this value. This is equal to WU divided by 8 into span is 5 meter, 5 square. So solving W is equal to 23.45 kilonewton